Hey guys, this is Shayan and today I'm gonna talk about recursion. In computer science, recursion is a way to solve problems by solving smaller instances of the same problem. To completely understanding it, let's take a look at a few examples. Assume that we want to calculate factorial of some number n. Well, the definition of factorial is like this: n factorial is equal to n times n minus 1 times n minus 2 to 1. For instance, 1 factorial is 1, 2 factorial is 2 times 1, which is 2, and 3 factorial is 3 times 2 times 1, which is 6. And 0 factorial is 1, just by definition. So let's forget about why the 0 factorial is equal to 1. Just by definition, assume that it is equal to 1. And now assume that we want to calculate n factorial. Well, one way to solve it is by recursion. I can say that assume f of n is the answer for n is equal to n factorial. Well, what I can say is that n factorial is equal to n times n minus 1 times n minus 2, 2 and 1. Well, I can say that if I consider this part is n minus 1 factorial. By definition of n factorial, n minus 1 factorial is gonna be n minus 1 times n minus 2 and so on. So I can say that n factorial is equal to n times n minus 1 factorial. In other words, I can say that f of n is equal to n times f of n minus 1. And this is what I meant by solving a problem, by solving smaller instances of the same problem. Here, I will solve the same problem for n minus 1, and using that, I will solve the problem for n. So I can say that f of n, and assume that n is a non-negative number, is equal to, if n was 0, I just return 1. And if n was greater than 0, I can just say that f of n is equal to n times f of n minus 1. So by doing this, I can calculate factorial. So let's go and implement this. Okay, now I want to implement factorial. I just say int of main. I want to define a function fact, which is my f, the f that I defined earlier. I can say that it gets some value n, and I will return n factorial as the answer. I can just say that if n was equal to 0, I can return 1. Otherwise, I can just call the same function for n minus 1, give n minus 1 as the input, and multiply it by n. This way, I will have n factorial using the solution, the answer to n minus 1 factorial. So I'm solving this problem by solving the same problem on smaller instances. So now if I just get an input as the input, I can get the n and just see out factorial of n. Okay, let's see whether it works or not. Okay, I can give as inputs number 5, and it gives us 120. And this sign in the end is because we didn't finish the line. So if I just add an end line in the end, it doesn't show that either. So for 5 is 120, which is correct, because if we calculate this number for 5, we can have 5 times 4 times 3 times 2 times 1. And this is gonna be equal to 5 times 4 is 20, and 3 times 2 times 1 is 6, and if we multiply these two numbers by each other, we're gonna have 120. So it's doing fine. And for 3, it's gonna be 6. So this is how we can implement and calculate n factorial using recursion. Now take a look at another example. Okay, as another example, let's now consider the Fibonacci sequence. Well, Fibonacci sequence is a sequence like this: 1, 1, 2, 3, 5, 8, 13, and so on. Well, in this sequence, each number is the sum of its two previous numbers. For example, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and so on. By adding the previous two elements, we will have the next element. So we can say that it's like in our sequence, if I show the number I with f of I, if I show the elements I with f of I can say that f of I is equal to f of I minus 1 plus f of I minus 2. So I can say that it's like f of, for instance, 0 is 1, f of 1 is 1, then f of 2 is 2, then f of 3 is 3, f of 4 is 5, and so on. So we can see that we get the same sequence. Now again, we see a recursive equation in here. For f, I can say that the element I is equal to its two previous elements. So if someone gives us the value of I and wants us to give him or her the value of f of I, we can just say that we will solve the problem for I minus 1 first and for I minus 2. And then we add these two numbers to get f of I. So we can simply calculate this value as well. Let me define another function in the same code. I can say that int of fib, it gets some number n, or it gets I. There's no difference. Let's assume that it gets I. I can just say that f of I is equal to, if I is equal to 0 or I is equal to 1, I can just return 1. I can just assume that the answer will be 1. So for just two values, I just keep the answer. I just say that it is equal to 1 for I equal to 0 or 1. And for I greater than 1, I just say f of I is equal to f of I minus 1 plus f of I minus 2. And this way I can just implement it. Fib of I can be the elements number I of Fibonacci sequence. We call this sequence, as I mentioned, the Fibonacci sequence. It is a very famous sequence in computer science and mathematics. So you should be familiar with this. I can just say that if I was equal to 0 or I was equal to 1, return 1. Otherwise, I can just return fib of I minus 1 plus fib of I minus 2. So now let's this time see in some value of n and see out, print all the values of fib of I for all the values from 0 to n. I just say cout fib of I, and I will have an end in the end. So now let's see how this one works. If I give, for example, 6 to it, it will give me 1, 1, 2, 3, 5, 8, and 13. So it gives me the Fibonacci sequence as I wanted. So it's working properly. This is another instance that we are solving a problem by solving the same problem on smaller instances. So let's see what's really going on in here. The first function that we defined the factorial, when I was calling, for example, factorial of 3, then inside of this function that you can see in here, I say that factorial of n is equal to factorial of n minus 1 by n if n is not equal to 0. So it first calls the factorial of 2. It first wants factorial of 2 to be solved. Then factorial of 2 itself will call factorial of 1. Then factorial of 1 will call factorial of 0. Then in here I see that I said, as you can see in the code, if n is equal to 0, return 1. So in here I will say that the answer is 1. So the answer that I return here is 1. Fact of 0 will be 1. So fact of 1 now has the answer of fact of 0. Now it multiplies it by n, which is 1 in this case, so it will return 1 as its own answer. Then 2 receives 1 and multiplies it by 2, so it will return 2. And return 2 to factorial of 3. And it receives 2 and multiplies it by 3. Therefore, it returns 6. And this is how, by calling this function, we will get number 6. The same thing is happening in Fibonacci sequence. For example, when I call fib of 5, first it calls fib of 4 and fib of 3. It calls fib of 4 and fib of 3. Then from fib of 3 it will call fib of 3 and fib of 2. Then from this fib of 3 it will call fib of 2 and fib of 1. Then here again from fib of 2 it will call fib of 1 and fib of 0. In here fib of 1 will be 1, so it will be calculated as 1 and it will return 1. Fib of 0 will be also 1. Then fib of 2 will be the sum of these two numbers, so it will return 2 as the sum of these two numbers. Then in here, in fib of 1, it will again return 1, because as you can see in the code, I said that if I is equal to 0 or I is equal to 1, return 1. Therefore, fib of 3 will return 3, because it's the sum of the two functions that it calls. Again, here, fib of 2 will be equal to fib of 1 plus fib of 0. Both of them will be 1. They will return 1, so fib of 2 will be 2. Therefore, here fib of 4 will be 5. Again, here the same process will happen, and fib of 3 will be equal to fib of 2 plus fib of 1, so it will call these two functions. And then fib of 2 will call fib of 1 and fib of 0. Both of them will be 1. Both of them will return 1. So fib of 2 will return 2. Fib of 1 here returns 1. And fib of 3 here returns 3. Therefore, fib of 5 will be the sum of these two numbers, and it is going to be 8. This is how fib of 5 will be calculated. As you can see, it will call many instances of the same problem with smaller values of n or I, whatever. So, therefore, we are solving the same problem over and over again. But as you can see, there's something different in here. In Factorial, we had only one pass, but in here we have many branches. And we are calculating many numbers. And as you might felt, there are a lot of calculations that we are doing them over and over again. For example, here I'm calculating fib of 3 and I know that it is 3. But here again I'm computing fib of 3. This is not a good thing. This makes my code slow. Or I'm calculating fib of 2 here and I understood that it is 2. but I'm again calculating it over and over again. So maybe if I can somehow save that what are these values and avoid calculating them over and over again, I will save a lot of time, and that would be a lot better. This is what I'm going to talk about in my next video about memorization and dynamic programming. These two things are very important in computer science. So if you comprehend these recursive functions very well, I recommend you to go and watch that video as well. You can ask me any question about this topic in the comments below, and I will try to answer all of them. Also, if there is any other topic that you want me to talk about, you can tell me and I will make a video about that. If you like my work and you want me to continue doing this, you can support me by liking this video and subscribing to my channel. Also, please send this video to anyone that this video might help him or her. Thank you very much.